Hi, welcome back. In our previous lesson, we started with the Lagrange method of solving the consumer's optimizing problem. Today, we'll be moving on to deriving the optimal demand functions. So in our previous lesson, we used the Lagrange method to find the utility maximizing bundles of good X and good Y for values of income and prices of the two goods. So we showed the various steps involved in doing this. Today, we are going to leave prices and income as variables and solve for the utility maximizing quantities of good X and good Y as a function of Px, Py, and income. So what we are going to do here is simply leave the budget as it is shown here without including specific numerical values for income, price of good X, and then the price of good Y. So in this case, a Lagrangian function is simply going to look like it is here, where we have our utility function, which is the function to be maximized, plus our lambda multiplied by the budget constraint. Following the steps from our previous lessons, we will now differentiate the Lagrangian function. So the first is to differentiate the Lagrangian function with respect to x. So in doing this, we have 0.5 x minus 0.5 y 0.5, and then we have minus lambda px being equal to 0. This can be rewritten as 0.5 x minus 0.5 y 0.5 being equal to lambda px. So let's call this equation 1. So the next is to differentiate the Lagrangian function with respect to y. We have 0.5 x raised to the power 0.5 y raised to the power minus 0.5. Then we have minus lambda py, which is equal to 0. Then we can rewrite this as 0.5 x raised to the power 0.5 y raised to the power minus 0.5 being equal to lambda py. Let's call this equation 2. Then the next thing is to differentiate the Lagrangian with respect to lambda, which simply gives us income minus pxx minus pyy being equal to 0. This can be rewritten to give us our budget, which is pxx plus pyy equals income. Let's call this equation 3. Now, just like in the previous lesson, the next step involved dividing this equation 1 by equation 2, and whatever the simplified function is from that approach, we simply substitute that into equation 3 to solve for our demand functions. So let's first divide equation 1 by equation 2. So equation 1 is 0.5 x minus 0.5, then y raised to the power 0.5, which is equal to lambda px. And this is divided by equation 2, which is 0.5 x raised to the power 0.5, y raised to the power minus 0.5, which is also equal to lambda py. Now we have shown the simplification process of this equation in our previous lessons. So we're simply going to go ahead to rewrite this as yx equal to px over py. This is obtained by cancelling out our lambdas and the 0.5 and simplifying the rest of this equation to get y divided by x. And what is left here is also px over py. So this shows our two slopes being the same, which is the marginal rate of substitution being equal to the ratio of the two prices, which is our equilibrium condition when there's interior solution, the slope of the indifference curve being equal to the slope of the budget line. Now let's move on to simplify this equation further. So our marginal rate of substitution, which is y over x being equal to px over py, can be simplified further as y equals px over py multiplied by x. So we are going to substitute this equation, if we call it equation 4, back into our budget, which is equation 3, to obtain our demand functions. Our budget, which is pxx plus pyy being equal to our income. So we know to be equal to the ratio of the prices multiplied by x. So we simply substitute this in to get EY multiplied by the ratio of the prices, and then X equal to income. This is simply going to give us PXX plus PXX equal to income. So this is 2PX multiplied by X equal to I. So X is therefore income divided by 2PX. Now we know Y to be equal to the ratio of the two prices multiplied by X. So then we can find Y as the ratio of the two prices being multiplied by X, which is I over 2PX. Now, if we cancel these 2PX, then our Y simply I divided by 2PY. Now, these are the demand functions for the two good X and Y respectively, because they show how the quantity of each commodity varies with its price. So this is all that we have on our lesson on deriving the optimal demand functions. Our next lesson is going to look at what information we can get from these demand functions. If you enjoyed today's lesson, consider subscribing. Thank you.